Okay, let's talk a little bit about the history of the atom. So by the end of today's lesson, you should know the conclusions of the gold foil experiment. It's one of the most important experiments in the history of chemistry, and we'll talk more about that in just a minute. And then you should know how to draw an atom based on the Bohr model, again, which we'll talk about. So let's go back to 400 BCE, and we have our first kind of idea of what atoms would be like. So we have the Greek philosopher Democritus. He was kind of the first person to come up with this idea of atoms. So Democritus came up with the word atomos. And so essentially he thought if you take something like a piece of bread and you cut it in half, and then you cut it in half again, and then continue doing that, eventually you're going to come to a spot where you can't cut it in half anymore. And that piece of material that you can't cut in half anymore would be the smallest piece of matter, and that's called, he called it atomos, and atomos essentially just means uncuttable or indivisible. He also said that atoms cannot be destroyed. And then lastly, Democritus thought that they were solid balls. So he thought that they, meaning atoms, were solid spheres. And because this was so long ago, again, 400 BCE, that's a long time ago, we couldn't really do any scientific experiments to prove their existence. So fast forward about 2,200 years, now we're in 1808 AD. And our first chemist that we'll talk about is Dalton, or John Dalton. He was the first one to actually do experiments to prove the existence of atoms. And he actually had a similar theory to Democritus, what he came up with. And so his theory was that atoms cannot be created or destroyed. And then he also thought that in chemical reactions, that atoms were combined or just rearranged. So not too much more than what Democritus had said. But if you fast forward another, we'll say about 100 years, so 1904, now we get this guy named J.J. Thomson. And he actually discovered what's called an electron, which if you haven't learned about those yet, you will very soon. He discovered the electron. And electrons are tiny, negatively charged particles within atoms. So atoms have these tiny negatively charged particles. They're called electrons. And so what J.J. Thomson thought after he discovered the electron was he came up with what's called the plum pudding model, or some people call it the blueberry muffin model. So when he came up with his first drawing of what he thought atoms looked like, he kind of was going off of what Dalton said and that they were spheres, but he thought that there were also pieces within them. So he kind of thought there were these little negatively charged particles within the atom. And so these would be the negatively charged electrons. And then if you think about a blueberry muffin, you can kind of think about this in the same way. So the blueberries within the blueberry muffin are like those negatively charged electrons, and then the dough, or the rest of the stuff in the atom, would be the positively charged piece, because the atoms were electrically neutral, or they had overall no charge. So you needed a positively charged quote-unquote dough, and then the negatively charged electrons just kind of floating around in there. All right, so let's go forward another few years. So we still haven't quite figured out yet what the atom actually looks like. So now in 1911, we have this man named Ernest Rutherford. And he's the guy that actually did the gold foil experiment. Whoops. He's the guy that did the gold foil experiment. And so I'm just going to draw for you an overhead view of what the gold foil experiment was. So essentially he took a very thin piece of gold foil. It's a thin gold foil. I'll even color this in so it looks more like gold. So we took a thin piece of gold foil, and then he took a detector. I'll draw this in blue. And he placed a detector around it. And the detector detects positive charges. Okay, so the detector detects positive charges, and then he essentially shot a beam. So this is a beam of what are called alpha particles. And alpha particles are positively charged. Okay, so he took a beam of alpha particles, which are just positively charged particles. He shot them at the gold foil, like so. And then what he found was that the detector was picking up a lot of positive charges past the gold foil. So all of those positive charges were going straight through the foil. And every once in a while, one piece of the beam would bounce back at the detector. So a good portion of the beam was going straight through the gold foil, and I'm going to write up here. So most of the alpha particles went right through the foil. So they were just going straight through it. And now this over here, these beams that were bouncing back, I'm going to say that very rarely some bounced back. So let's think about what this means. So his conclusion, or we could say what's actually happening. So Rutherford kind of thought that the explanation for this would be that atoms have a very small positively charged center, and then around the outside, essentially he thought that the beam of alpha particles were essentially just going straight through the atom. Oops. So because all of these particles up here were going straight through the gold, he kind of thought that the gold atoms, or any atoms in that case, are essentially mostly empty space because a lot of those particles were just passing right through it. However, once in a while, one of the positively charged alpha particles would hit a positively charged nucleus, and because two charges that are the same, both positive charges, they would essentially repel each other. So a positive charge repels another positive charge. And so when it would hit the nucleus, it would essentially just bounce back. But that happened very rarely because the nucleus in the atom is so tiny. And this is I'm going to put this just for clarification. So this is a close-up of a gold atom from the experiment. So the conclusion of the gold foil experiment, and these are two things that you should definitely remember, that the atom is mostly empty space, and that atoms contain a small and dense positively charged nucleus. And the nucleus is just that center part, or the center of the atom. Okay. So this took place all in 1911. Now we're going to fast forward 2 more years. So we're almost to where we're at now. We're going to talk about someone named Niels Bohr. So Niels Bohr took Rutherford's model that he drew, but he added a little bit to it. So rather than electrons randomly placed around the nucleus, he said that electrons were organized into orbits around the nucleus. And so when Bohr drew his model of the atom, he said that the nucleus is at the center of the atom. It's very small and dense. And then around the nucleus, we have these rings or orbits. And that's where the electrons would be located. And this is still how we draw atoms today, even though it's not exactly what they look like. This is just a simplified model that we still use today, over 100 years later. Okay. Now, in the 1920s, this is what we call the modern version, or the wave mechanical model. So Schrodinger, if you ever heard of him, he's the guy that did the famous Schrodinger's cat experiment. He came up with the wave mechanical model. And so this is what we still use today. So he concluded that electrons exist in regions of space around the nucleus, very similar to what Bohr said above. And he called these orbitals. He also concluded that the exact location of an electron is never known because they move just too fast. We can't know the exact location of an electron around the nucleus, but he said that orbitals show the most probable or most likely spot that electrons are found. So orbitals just show the most probable spot that electrons are found. And then lastly, atoms consist of a nucleus surrounded by an electron cloud. Okay, so essentially what we need to know is how to draw these Bohr diagrams. So the nucleus always goes in the center. It's also very small, positively charged. Eventually we'll learn what the nucleus is made of. And then you also have these electrons kind of flying around the nucleus in what's called the electron cloud. Those are also in orbitals.